Number 7. Upon what two things does pressure in a fluid depend? Brandon.
Depth and weakness.
Yes, so depth. And I'm just going to be a little less specific and call it fluid density. It's whatever the fluid is. Good. Depth and density of the fluid. Those are the two things that you need in order to have pressure. So the more depth you have, the more pressure you have, and the denser the fluid, the more pressure that is. For example, if you go down like 10 feet under the water, you can feel the pressure, but you can't feel the pressure really here on the Earth, even though we got miles of air above us, but the density of air is much, much, much less, so you don't notice it as much. And as you go down deeper in the water, you notice more and more pressure building. Okay, why is it that depth increases pressure? Why does depth affect it? We know that depth does. It's one of the two things. Why does depth?
Would it be it multiplies the density?
Well, yes, but why?
Because I'm not sure. It'd be on top of you or something.
Yes, there's more stuff on top of you. More weight of fluid above. Lucian, keep with the computer up. All right. So, the amount of water does not affect pressure. Give and explain an example where a small amount of fluid could apply a higher pressure than a large amount of fluid. So the amount of water isn't important. What's important is these two things, depth and fluid density. So how is it you could have a small amount of water impacting a larger force? Chase.
I turned off the picture a small bit.
Yes. So if you have a really large but shallow lake, and you compare it to a really small but deep pond, this has more pressure. Because there's more depth. So the fluid density is the same, but the depth is not. So the more depth you have, the more pressure you're going to build. All right. Explain the picture on page 247, 15.3, or 13.5, sorry. What does that show about pressure? What is that picture explaining about pressure?
I said it's because pressure depends on depth, not shape.
Yes. Pressure depends on depth, not shape. Okay, 11 was tricky for a lot of people, so I'll do this one. What does the phrase water seeks its own level mean? Use an example to explain this. So what it means is that water wants to balance on the surface. So any changes in depth, water will fill in and then level off. Okay? So an example I like to use is the depth of lakes is not uniform. So there's shallower areas, there's deeper areas, something like this. But water will balance all of them out. So water will level itself off over the entirety of it. So there'll be places with more depth, places with less depth, but water will be balanced over the surface. The book uses the aqueducts in Rome as an example because they could get the water uphill by just having, so it seemed like it was going uphill, but really the water was still going downhill from its perspective. So if you built the aqueducts high enough, it would look like it was going up these hills, but really water was just leveled out. So that's the idea behind that. All right, in what direction is the pressure from a fluid exerted? So what direction is pressure exerted, not force? The next one's force. What direction does the pressure go? All directions, yep. All directions. So what direction is the force? The force is perpendicular to the surface. So if you're feeling pressure in all directions, but the direction of the force is perpendicular to the surface. So if you're talking about pressure, pressure is everywhere in the water. But if you've got a box underneath the water, the force is perpendicular. Like that. And that's why we say force is in all directions. The force or the pressure is in all directions. The pressure is down, pressure is in, the pressure is up, the pressure is to the right. But the direction of the force is perpendicular. It doesn't come at an angle, it comes straight in.